So what are the benefits of data visualization? Well, data visualization prospectively affects the organization's decision-making process with interactive visual representation of data. Businesses can now recognize patterns more quickly because they can interpret data in a graphical or pictorial form. Here are some of the specific ways that data visualization can benefit an organization. Starting off with correlations in relationships, trends over time, frequency, examine the market, risk and reward. Let's see each of these in detail, right? Starting off with correlation in relationship. Without data visualization, it is a challenge to identify the correlation between the relationship of independent variables. By making sense of those independent variables, we can make better of the business decisions. Then we have trends over time. While this seems like an obvious use of data visualization, it is one of the most valuable applications. It's impossible to make prediction without having the necessary information from past and present. Trends over time tell us where we were and where we can potentially grow. Then we have frequency. Closely related to trends over time is frequency. By examining the rate or how often customer purchases and when they buy gives a better feel of how potential new customers might act and react to different marketing and customer acquisition stages. Then we have examining the market. Data visualization takes information from different markets to give you insight in which audience to focus your attention on, which one can stay away from. We get a clear picture of the opportunities within those markets by disciplining its data on various charts and graphs. Risk and reward. Looking at value and risk metrics requires expertise because without data visualization, we must interpret complicated spreadsheet and numbers. Once information is visualized, we can then pinpoint the area that may or may not require an action. Now that we know the importance of data visualization and how it is being used in real world, let us now take a look at various tools for data visualization. If you're someone who thinks we have few tools for visualization, well, let me tell you, we have a lot of tools for visualization. Some visualization tools are dedicated software, for example, Tableau, Power BI, TensorBoard, and many more. And some are built in with a language such as with Python, we have Matplotlib, Plotly, Sleepon, and many more. Alright guys, so let us now do one thing. Let me now take you to my code editor and take up a small data set from Kaggle on IPL dataset, which would range from all the matches from 2008 to 2020. And let's see how we can find relationship between most of the independent parameters and also see how we can visualize them on a graphical scale. Alright guys, the dataset that I'm going to use over here is one of the popular one, that is IPL dataset. And thing over here is I'll be having all the records of all the matches and all of the events that have happened during the IPL matches all the way from 2008 to 2020. So first off, what we're going to do is, first off, we need to import a library, that is pandas. So import pandas as pd. Let us also import numpy and as np. Similarly, what I'm going to do is we'll also import matplotlib. And finally, let us also import another visualization tool, that is Seaborn. So I have already installed all of these libraries. By any chance, if you haven't installed these libraries, all you can do is you just have to do this exclamatory mark and use the pip command, pip install Seaborn or any other library that you want. And let me quickly execute this now. So as you can see, we have imported this. So the next thing that we want is to get our data. So let me give a comment here. So load data. To load our data, first we're going to use pandas. Pandas here we have given as pd.readcsv, and this is present in my current working directory. And the data set that I'm going to use here is IPL matches from 2008 to 2020. And let us also give this a variable name here. We'll say it as data. And let me execute this now. So now we have loaded our data. Let's see how our data would look like. So just to see how our data would look like, all I'm going to do is data.head and let me hit enter. And you will see all the list of columns and rows that is available here in brief. Now, if I want to see the last 5 data set, all I can do is I just need to give here as -5 and hit enter. This would first off give me the first 5 data set and also the last 5 data set. And now apart from that, another useful tool that we can do here is data.info. And what this data.info does is it gives us a summary of every column. So now, for example, we have city, date, player of a match and all that. So here we can see here. So player of a match, venue, and it will tell us what is the data type of that particular object. And it also tells how many non-zero values are there. And how to determine what is the total number of values, you can just use the ID. So ID cannot be null. If ID is null, that means that that particular row doesn't exist. So here we have total number of values as 816. So you can see here we have 803 non-null values, which means over here we have like 813 minus 803. That is somewhere around 813 values are there and 3 values are missing over here. And here, as you can see, we don't have any missing values. Similarly over here. Now what's going to happen here is, you can see here method. So method here has a lot of null values. And at the same time, we can say here only method has a lot of null value. So what I can do is I can just drop the method over here. So to do that, what I'm going to do is data dot drop. And now all I'm going to do here is pass this value method. So let me copy this and put this in a form of a string here. And let me give a comment. Drop the method feature. As I've mentioned, the reason I'm dropping the method is because we have a lot of null values, and as long as we have null values, we cannot perform any computation. So now let me execute this, and you can see we're getting an error. The reason why I'm getting this error is because I have not defined an axis. So defining an axis when you're trying to drop is very important. So let me give here as axis, and axis, if I put 0, it means it removes a row, and if I put 1, it means it removes a column. So I want the entire column to be removed, so it's going to be 1. So as you can see here, this method isn't there. But you know what? Still, we have to update this data frame over here. So in order to do that, let me show you what I'm trying to say. If I type here data.info, you'll see that, this method still exists. The reason is because I have not updated our data set. And there are two ways you can do it. Either you can assign this data over here and create a new variable data, or the other way you can do is use in place. So if I put here comma, in place is equal to true, this would save us the time of assigning new variable. And I'll just hit enter. If I click on this data.info again, and you will see here that we won't have this method. It's not there over here. So now what we're going to do is, let's try plotting a couple of values. And as we have already imported our libraries for visualization, that is matplotlib and seaborn, now let's see what we can do here. So first off, what we'll do is we'll plot a pie chart wherein whichever team has won and how many times they have won. And we are going to represent this in the form of a pie chart. So let me give the comment here and heading which goes something like most wins in IPL. So for that, first we'll take a temporary variable here. And as we know, we have pd.dataframe. And now what I'm going to do here is I'll create a data frame here, winner, winn, and the data that this key holds is data.winner. I hope you understand what this data.winner contains. So as you can see here, data.winner over here contains nothing but the name of the teams that have won that IPL match that particular year. So this is what data.winner does. And what I'm going to do here is we have created this data frame which has winner in this. And now what I'm going to do is count wins, because we need number of times these people have won. So count wins. So there will be temp.values counts. And now we are going to print count win. This would return us the number of times these people have won. So Mumbai Indians have won this match 120 times throughout the IPL. And then we have Gujarat Lions, we have Deccan Chargers. Similarly, we have Kolkata Knight Riders over here in 99 wins, total number of matches that they have won. And now what I'm going to do is I'm going to give the label for this. So labels. So I'm going to create a list x of 0 for x in countwins.key. So countwin is nothing but a dictionary, and key over here is nothing but Mumbai Indians, Chennai Super Kings and all that. So let me quickly give that up here. Dot keys, let me hit enter. As of now, let me comment this and let me see what our labels contain. As you can see here, x is not found. The reason why I'm getting that is because this has to be in uppercase. And let me execute this once again. So as you can see here, we are getting the list of all the teams that have won. And now we are going to plot this. So to plot, what I'm going to do here is I'll take plt.subplots. Here I'm going to give the figure size. Let's say 20,12. And here we'll give a reference variable here bar. comma axis. And now we'll have AX, this would be equal to PLT dot pi. And now here X, which is going to be count wins. So it's going to be this part over here, count wins. And then we also have to give the labels. So labels, this will be nothing but the labels that we have captured here. All right, so let us also provide the title for this, plt.title. So here will be most wins in IPL. And then we'll also assign a font size for this. This would be equal to, let's say, 17. And let me execute this. So yeah, I don't want this text over here. So what I'm going to do is plt.show. So now what I want is, you have a pie chart here which represents how many teams have won how many number of times. But just by looking at a pie chart, it's pretty impossible to predict the values. So for that, what I'm going to do here is, when I'm plotting a pie chart, I will also pass another argument here. So this argument would be something like autoplot CT, and here it's going to be as simple as percentage dot 1f, and then also pass percentage over here, and let me execute this. So as you can see here, throughout the matches that we have, total number of matches, Mumbai Indians have won 14.8 number of times. Similarly, Chennai Super Kings have won 13.1 times, and Kolkata Knight Riders have won 12.2% of the times. This is one attribute that we have visualized. So most wins in IPL. All right, so moving ahead, let's take one more value that we can plot. Let's see what we can do, right? So let's take this eliminator over here. And let's see how many number of times there is the most number of wins in the eliminator. So let me give as a comment here. So most wins in eliminator. So most wins in eliminator. So for this, what I'm going to do is, it's pretty simple. We won't be creating any list here or something. I'm going to use cbon here, cbon.countplot. And now all I'm going to do is pass the value. So data of winners. And here I'm also going to pass another list, data of eliminator. And those people have won in this, so it will be equal to y. And the data that this belongs to is our data plot over here, data frame. So data. And let's give the title for this, plt.title. So there'll be most wins in eliminator round, most wins in eliminator. And let's also give a font size. Let's keep it uniform. Let's see what font size we have given here. Let's give it as 17. And also, if I plot this right away, so we are having an error here. It's just a key error. So what I'm going to do is, I might have done a small typo here. So let me just copy this and paste it over here. And let me execute this. You can see here the bottom in the x-axis, all of these values have been merged. So we can just change that up by using plt.xtricks. So we have xtricks, and we'll just rotate this. Rotation, we will rotate this by 90 degrees. And also, I don't want this text part over here, so I'll use plt.show. And yeah, so as you can see here, we have most wins in eliminator, and yeah, we have also rotated our X ticks over here. As you can see here, Rajasthan Royals have won 2 times or 20 times. And then we also have Sunrise Hyderabad, who have won 1 match, and so on and so forth. All right, so let's see what other values we can extract from our data set over here. Point that I would like to mention is, when you're trying to perform EDA, whatever we are doing now is called as EDA, that is exploratory data analysis. It is very important that you are a master of that particular field. If I'm someone who's totally new to this data set, for example, let's say I don't know anything about IPL. So apart from the team and winner, I won't know the rest of the thing. I don't know how the internal working of this particular system works. So it's pretty important, and I would like, this is something which most of the time people make a mistake, that they don't end up knowing or having enough knowledge about that particular domain. So domain expertise is very important when you're trying to perform EDA. Let's take this toss decision, looks interesting. So when we are looking into toss decision, we need toss winner, and we also need who has won the toss and what they have decided to do with the toss. So let me quickly give this comment here, title. So let me give toss decision. So first off, what we're going to do is, we're going to capture the teams, TEAMS, and this would be data, and here we'll give toss winner. And we need unique values, because obviously it's like throughout the years, it's not just that, it's not restricted that a team should win only once in their lifetime. So multiple teams would have won multiple times. And as this was written as the NP array, we can use unique function, which would give us the total teams that have won. So unique, and then we'll hit this bracket. And then let's see how this teams would look like. So this is a small typo that we did. So as you can see here, these are the total number of teams, and let's try finding out some more information. So now here we'll take decision making. This is nothing but a variable that you're doing. So we'll create a data frame, pd.dataframe, and for this data frame, first off, we'll have an empty list here. We'll give the column names here as toss winner. We'll give decision, and then we'll take the time. So this basically tries to say how many times they have won. So now we have created a data frame here, and here this will be the list of the columns that we'll have. And now we obviously have to add values to this data frame. So for this, we'll be iterating using a for loop. So first off, what I'm going to do over here is we have to update these values. I'll be using this for loop. So for element in teams. This is nothing but this teams. But I don't want this. I also want the IDs. So what I will do is for ID comma element in enumerate. So ENU enumerate, and now I'm going to pass teams. So we'll have this list of teams here. So let's take some variable over here, team.bat. So here will be data, and now we are going to pass a value like this. So data and toss winner is equal to element. So basically, if I go here, if I have to show you what I'm doing here, let me take you to the data set. So toss winner contains this part. So toss winner can be Royal Challengers, Chennai Super King, Rajasthan Royals, Mumbai Indians, and whatever it is. So what's happening over here is, so if the toss winner, I'm from taking toss winner, is equal to element. Element is nothing but these values over here. And at the same time, we have data of toss decision is equal to bat. So what this line over here, temp bat, is trying to say is, if the winner, like, okay, we have this list of people, this returns as the list of teams. So now if the list of teams is equal to element and they chose to bat, like for example, Royal Challengers won the toss and Royal Challengers chose to bat, then append this to this value, then append to this decision making. So similarly, I'm going to do this for fielding. I'm going to copy this temp bat and let me paste it over here. And instead of bat, it will be field. And this everything would remain the same, and only thing is, instead of toss decision, it's going to be field over here. And now what we are going to do is we have to append this to this decision making, append to decision making. So what I'm going to do here is decision making. Let me copy this. So this would be nothing but decision making dot append. So here we have toss winner. So toss winner, and this would be element, and then the decision that they have taken, that is bat, and number of times they have chosen to do that. So times, so it will be TEMP. That is basically we are trying to do this over here, TEMP underscore bat dot counts. So as we cannot fit the entire thing in one line here, so I'll just go down, and we'll also add one more thing here. We don't want the index, so ignore index, and this would be true. So this is decision making only for the sake of bat. So let me do the same thing for fielding. For that, all I'm going to do is copy this and change this from bat to field. So this will be field. So let me just quickly brief up what I have done here. First off, I'm taking the teams that have won. So it will be teams, and it's going to be unique values, and this would return as a list of array, and which has the names of the teams. And now we are going to create a data frame here, creating a new data frame which has toss winner, decision, and time. So we'll iterate this. We have to fill this decision making. So for that, we are going to iterate this over teams. So teams would return as ID and element. So what I'm going to do here is ID is nothing but the 0, 1, 2, 3, so on and so forth. So now what's going to happen is we are going to take the toss winner, whoever has won the toss and they chose to bat, and the people who have won the toss and they chose to field. And obviously we have to append this value to our decision making. So this is what I have done over here. And let me quickly execute this now. So we don't have any errors. Now what we're going to do is, let's see what's there for us in decision making. Because all this we are doing in this particular box or block is appending the value to decision making. So as you can see here, we have toss winner, decision, and number of times they have won. So Royal Challengers Bangalore, they have won the toss 24 times and they chose to bat that time. At the same time, Royal Challengers Bangalore, they have won the toss another 24 times and they chose to field. And just to give you another insight, so we have Gujarat Lions, they have won the toss once, wherein they chose to bat and field once. So now what we'll do is we'll plot this thing over here. So to plot this, what I'm going to do is SNS, that is cbond dot cat plot, and now we'll give here the value of x. This will be toss winner, that is nothing but this part here, toss winner. So let's say toss winner, and then we have y, that is the number of times they have won the toss, that is nothing but this column times. We also have to differentiate like whether they have chose to bat or field. So for that we'll have u would be nothing but decision. So this is u, and let me fix this over here. And all of these belongs to what data? It belongs to decision making. So data is equal to, what I'm trying to say is it belongs to this data. So let me copy this and paste it over here. And we also have to define what kind of graph that we are trying to use. We are going to use a bar graph. So I'll give kind over here. So this will be bar. Couple more things, height. So we'll give height as 5 and aspect would be 2. And apart from that, let us also add plt.xtrix. So we don't want all the values to merge. So we'll just rotate by 90 degrees. So let me add a couple more attributes. We also want title, plt.title. And here we'll say title to be something like top, or it will be toss decision per team of teams. And we'll also give some X label because we want to show what our X side of the data represents. So X label here is nothing but IPL teams, and similarly Y label. Y label over here is toss decision. And yeah, this should be sufficient. What I'm going to do is let me execute this block of code here. As you can see here, we are getting the visualization of whatever data we have over here in this particular table. Whatever data was present here, we have just put that in a graphical form. Let me also try removing this text over here. So it will be plt.show, and yeah. So if you can see here, let me zoom out a bit to give you a better picture. So as you can see here, we are getting a bar graph. Here you can see Royal Challengers Bangalore. They have won the toss. Whenever they have won the toss for this many number of times, they chose to bat. You can say approximately 25, and other times they have chose to field. Okay, similarly, you can get it out for other. And as you can see here, this is something which I would like to say. Rising Pune Supergiant. They have won the toss over here. As you can see, they have never chose to bat. They have chose only to field over here. So this is what we can say. And let's take a couple more examples over here. We can also take, let's see what we have. Let's take venues. Venues also good thing. Let's see where famous venues that the matches have been played. So let me give a comment here. Let me say famous venue. So to get the famous venue, all I'm going to do is SNS. Directly we'll plot it up, bar plot. And now here data X over here is going to be data venue. And for Y we are going to have, so basically we're trying to see number of times they have played in the right. So for that we are going to use value count and dot head. The reason, as we have mentioned, it's not venues, number of times, it's a famous venue. So we'll have top 8. This would represent the value. And similarly for Y, what I'm going to do here is Y is equal to data, same thing, venue dot value counts underscore counts. Now obviously for top 8, so head 8. And as you can see here, we have taken values. So this would give us the number of times. I also want the index. So index will be over here, and the data that we are trying to get this from. So data, this would be nothing but data frame. So let me quickly execute this. So let us add a couple more values over here. Let's say plt.title. Let's say famous venue. And x label, plt.x label. So venue count. And at the same time Y label, plt.y label, so venue. So let me execute this. So as you can see here, we have top 8 venues, and these are nothing but the venues, and these are nothing but the number of times they have played. You can see over here in Karnataka, Chinnaswamy Stadium. They have played somewhere around 65 matches. Then you have Eden Garden, which is wherein they have played around 75-ish kind of matches. Oh, here we have famous venues. If I want to get to know all the values, so for that, what I'm going to do is going to remove this, and I'm going to remove the head because head is going to give me by default top 5 values. So I'll just hit this. So as you can see, we have a lot of stadiums and there's a lot of data over here. So for now, what I'm going to do is I'm just going to replace this by head here. We'll keep top 8 venues which are there. So if I want for the top 10, all I'm going to do is top 10. And so as you can see here, we get the top 10 venues. If I don't want this, I'll just put here plt.show and hit enter. Yeah. So this is how we can find out top 10 venues. So finally, let's do one thing. Let's see what other things that we can do. Some data that we haven't touched. Over here, we have this empire. So this empire data, something which we haven't touched over here. Let's try figuring out any relationship that we can get over here. So we have two types. We have empire 1 and we have empire 2. Let's see top 5 empire 1s. Let's try getting on visualizing that data. So here will be top 5 UMPI empire 1. So for this, all I'm going to do is directly jump for Seaborn SNS.barplot. And here in my X data, what I want is data. And I'm going to pass empire 1. And now similar to what we have done earlier, we'll have the counts as well. Value counts. And then we'll give head. Remember, head by default gives us the top 5 values. So head, and then we'll have index. Similarly, we need to do this for Y because we have to plot this across X and Y axes. So it's going to be the same thing. So let me just copy this. Instead of index, it's going to be values. So let me paste this over here, and this is going to be values. And now finally, the data that we're going to take this from is from our data set. And now what I'm going to do here is plt.xlabel we'll give here as empire 1, and then plt.ylabel we'll give here as match code. That is number of matches they have played, match count, and then plot title. We'll say top 5 empire _1, and then finally plt.show. Let us execute this. This is a key value error. So somewhere I might have gone with a typo. So let me quickly fix that up. So we'll copy this and let's go down here and we'll paste it over here. Oh yeah, I have given extra space. Let me just replace this. Similarly over here, and let me execute this once again. So as you can see here, we are getting the empire list. So here we are having the values that are like overlapping. So what we'll do is xtrix. So plt.xtrix will give rotation. Let's give it by 35 degrees. 35 is a bit too much. I want it to be a bit clean. So 45 degrees. Let's give 90 degrees itself. So as you can see here, we are getting the list of empire 1 and number of matches that they have looked after. And yeah, these are the top 5. If I want just top 10, you say. If I want just top 2. So all I can do is just give 2 over here. And yeah, so you can see we'll get top 2. And if you want top 6 or something, all you need to do is change the value of head over here. And we'll get top 6 empires over here. Similarly, before we end this session, let's have one more. We'll also do it for empire 2. So everything remains the same. So I'll just copy the same code over here. And let me paste it here. And this is instead of 1, this is going to be 2 here. And instead of 1, it's going to be 2. Now, only thing that I'm going to change over here is, as you can see here, I have put the values. I have put the values on the y-axis and index on the x-axis. So just to keep a bit different, so I'll give here as values, and this will be index. And similarly, I'm going to change this over here. I'll change this from match count. This will be somewhere over here. And here we'll give empire 2. And this is something similar. Only thing is the augmentation of this would change. And let me quickly execute this. So as you can see here, we have changed the augmentation. We have S. Ravi, the empire 2, who has played somewhere like 80 matches. The reason why we are getting in this manner is because we have rotated this. We don't want to rotate our graph. So let me execute this. So as you can see here, we have S. Ravi, who has won 80 number of times. We have RJ Tucker, who has played matches. who have supervised around 40 matches. Then we have Nitin Menon, who have approximately 36 or something. So this is how we can visualize our data. So now you might be wondering, why is this data visualization so important? Well, sometimes when you're trying to create a model, you want very specific number of values or data. And it's very important that we visualize and we also get so and so information just to create some relationships. So if you take an example of linear regression, we don't need to consider two values that are dependent on each other. With this plotting, right, we can find if any values are dependent upon each other or not.
So in this particular session, we'll be focusing on tweets related to Donald Trump and see what is the general public opinion or what is the general public sentiment regarding him. So let's start by fetching some relevant tweets about him with Tweepy. For those who don't know what a Tweepy is, let me tell you, Tweepy is an open source wrapper written in Python, and this will help you to communicate with Twitter platform and use its API. In our case, we'll be using it to read and write the tweets. But before using Tweepy, in order to authenticate yourself, you need to sign in to dev.twitter.com and create an app over there. Let me show you how our Twitter app looks like. So there's sample Twitter app which I have created as sentiment underscore analysis underscore edureka. Well, it's a very simple process. Just click on create app and it will just guide you through a series of steps. Just enter the details and your app is ready. All right. Well, the main thing to focus over here is this key and token access. Okay, for this particular video, I'll be just changing my consumer key and the secret key. Let's regenerate consumer key and secret key. Okay, it's done. And my access token key and my access token secret. Let me regenerate them too. So you need mainly 4 variables in order to prove your authentication. The consumer key, which is an API key, the consumer secret, which is an API secret, the access token, and the access token secret. All right, fine. So let's start by importing Tweepy. Import Tweepy. Next, as I said, I'll be using text blob. So let's import it too. So your Tweepy is done, your text blob is done. So the very first thing that I need to do is authenticate myself with those 4 keys I just discussed. All right. So let's define them: a consumer key, consumer secret, access token, and access token secret. Let me just copy paste them for you. There's my consumer key, my consumer secret. Next, my access tokens. These are my access token. All right. And the access token secret. Fine. There is something. Just make sure that you copy and paste it right. If you don't, you won't be able to authenticate yourself over Twitter. All right. You need to establish a connection between Python and Twitter. Fine. So what do you want to search? Well, like I want to search for Donald Trump. Donald Trump. So what I want, I'm telling Tweepy, show me some tweets regarding Donald Trump. Let's see what it gives. All right, the result is out here. So as you can see here, these are various live tweets which we have just fetched from the Twitter. As a result, you can see here we have a sentiment report which consists of the polarity as well as the subjectivity. Well, the sentiment score will depend on how clean your data is. More cleaner the data, more accurate will be your sentiment score. So this was all for this session. Stay tuned for my next video where I'll tell you how you can improve your sentiment score.
Once in every 4 years, the world celebrates a festival called FIFA World Cup, and with that, everything seems to change. Priorities switch to football, and predictions switch to the teams and players that would perform in the tournament. So, for all the football lovers out there, I hope that excites you. So, let's make this fun and let us see our problem statement first. But, guys, let me make it very clear that this list is based on my opinion only, and you are entitled to have a completely different opinion. So, if you do have a different opinion, let me know about your list in the comment section below. Now, as I told you that I'll be predicting the world's best and strongest 11 players taking part in this FIFA World Cup, and I would be using Python for the analytical implementation. So I'll start this analysis by first analyzing the world's best goalkeeper, then 4 best defenders, 3 best midfielders, and 3 best attackers. So if you notice over here, I'm following a 4-3-3 lineup. Well, it's often said that 4-3-3 is the best lineup, but obviously it is not fixed. So based on my players availability, I have choose this lineup as 4-3-3. So guys, it's totally up to you. You can choose any position you want. Now as I've said guys that I'll be using a 4-3-3 position. So here I have 4 defenders, red marked as 3 midfielders, blue marked as 3 attackers, and mustard orange for a goalkeeper. So I hope you guys are clear with this 4-3-3 position. So if you notice over here, I have a question mark on all these positions. Now why? Because this exactly my problem statement is. That is, I need to find out the players who will play the best in these respective positions. So this sounds pretty interesting, right? So let's begin an analysis. So here I'll be following 5 steps wherein I'll first load my dataset and then import the required libraries. Now I'll be using FIFA dataset from Kaggle. So don't worry about the dataset guys, I'll be mentioning the link of Kaggle website in the description below. So once you have loaded the dataset and imported all the required libraries, we'll then analyze it, explore the dataset, and then we'll figure out the best goalkeeper, the best defender, best midfielders, and best attackers. So let us go through all these steps one by one. Now my very first step is to collect, or you can say load the dataset and then analyze it. So if you notice over here, I have a screenshot which displays the dataset. So over here I have the name of the player, I have the nationality, that is the country he belongs to. Then I have the national position in which the player plays at the national level. Then we have the national kit, we have club position, club kit, and we have so many others like that. So this is a dataset which is provided by Kaggle. So I'll just mention this in my description box and you can just download the dataset from there. Now I'll be using different libraries as well. So over here I'll be using pandas for data analysis, manipulation, cleaning and all those stuff. Then I'll be using NumPy for the scientific computation part and matplotlib and Seaborn for visualizing plots. So in this step I'll be just loading my dataset and then importing the required libraries. So let me just go to my Jupyter notebook and let us implement all these steps one by one. So guys, this is my Jupyter notebook. Now, as you can see, we need to figure out the world's best playing 11. So over here, I have first imported all my libraries, that is import pandas as PD, then Seaborn as SNS, NumPy as NP, and then I've imported matplotlib. And then I've just written percentage matplotlib inline, that is to visualize the plots in the Jupyter notebook itself. Then what I've done, I have just read my dataset. So the name of my dataset is full data. Now using pandas, I have read the CSV and then displayed the top 7 rows. So over here I have already discussed that the dataset contains the columns such as names, nationality, national positions, and we have so many like that. So here I have just printed 7 rows and if you notice that we have 53 columns over here. So you can just go through it, explore, do experiment with them and gain insights out of them. So here if you see you have characteristics of all the players and their score. So you can just go ahead, download this dataset and explore as much as you can. Now, analyzing this huge dataset is a tedious task as it involves quite a few pre-processing steps as well. Now, there might be a lot of redundant and unwanted columns which you may want to remove. Therefore, you can delete certain columns if needed. So, let me show you that as well. So, here what I have done, I have deleted one column that is national kit. So, I don't require the column as national kit. So, what I'll do, I'll say delete. So, I'll just write DEL. DF is the name where I have stored my dataset and then I have just mentioned the column name. Over here, I don't want the national kit column. So I've just write this and then I've just printed the head of it. So once I run this, you'll see that the national kit column no longer exists. And if you notice, I just have 5 rows and 52 columns, whereas in totality, we were having 53 columns. Similarly, you can delete as many columns as you want. You can actually do a lot of transformation. You can remove the null values, that is nothing but the cleaning of data. So you can do the analysis on your dataset as well. So I'll just leave this part on you. So you can just go ahead and analyze as much as you can. Now, once you have simplified this data, you can then start with the analysis part. So to explore or you can say analyze your data, the best thing you can do is to visualize the data in the form of plots. So what happens with that is you can easily read out your conclusions. You don't have to calculate a lot of things. You don't have to play with numbers in fact. You can simply see that okay, this has the highest peak means this is the most likely outcome to be happen. So that is how you can visualize everything using Matplotlib and Seaborn libraries. So here what I have done, I have plotted a simple count plot which basically gives me the number of players representing a particular country. So over here I have count plot and on the y-axis I have the nationality and on the x-axis I have the count, that is the players count. So as you can see here from the graph, you can easily conclude that most of the players are from England, then from Argentina, Spain, France, Brazil and the list goes on. Now these graphs are best used to gain statistical insights. So you can just go ahead, plot with different columns and analyze your data set. Now in this case, the graph won't add a lot of value because we would be picking the best 11 and the results may vary accordingly. So these graphs are just for analysis part. So over here, the results that we got is purely dependent on your data set. So right now I'm getting the maximum count from England and then from the Argentina. So guys, don't take it personally, it's just displaying what my dataset contains. Now moving ahead with the analysis, you can try out different visualization. Let's say with the player's age, with the preferred position he plays, then the rating of it, then the club he is, and you have a lot more columns like that. So let me show you one more visualization and then we'll switch to an analysis of fetching the best playing 11 for the World Cup. So here I have again plotted a count plot wherein I have the player's age on the x-axis and the count on the y-axis. So here it is quite evident that the majority of players are between the age 20 to 29 and it has the largest peak at 25 years. So that is how you can conclude a lot of other things by just going through your dataset and taking up different columns and plotting different graphs with them. So now is the time we try and find answer to the question we put forth in the problem statement. That is, who will be the world's best playing 11? So let us begin our analysis. So as discussed earlier as well, I'll be using a 4-3-3 lineup, which means we need to find 4 best defenders, 3 best midfielders and 3 best attackers. And we'll be having one goalkeeper as well. So let us start our quest by finding a goalkeeper first. Now over here, as you can see, I have assigned some weights to these variables. So if you notice over here, I have given the minimum weight of 0.5 to the variable A, then I have given B as 1, C as 2 and the maximum weightage 3 to the variable D. Now I'll be telling you why we have assigned these weights and when we will be using these as well. Now in order to find the best goalkeeper, what I'll be doing, I'll be analyzing the data for the two parameters, that is the shot stopper and the sweeper. So a shot stopper is a goalkeeper who is strong in stopping the shots taken by the opponents, whereas a sweeper is a player who is quite strong in playing with his feet and making the passes. So that is why I have taken these two characteristics and then assigned all the weightage to the characteristics. Now in my dataset, I have various features such as we have reactions, we have a column of composure, we have the column of speed, strength, and we have many other features like that. Now that is why I've assigned weights to it. Now in short stopper, what I'll be doing, I'll be giving weightage to all these characteristics. So let's say I'm giving the weightage of A to the speed. Now A is the minimum weightage. And similarly, if you see for sweeper, I'm giving a bit higher value to the sweeper. Now why? Because sweeper is the one who sweeps up the ball if an opponent manages to breach the defensive line. So that is why I've given B weightage to him. Similarly, for jumping, I've given C weightage for short stopper and I've given lesser weightage for sweeper. Then moving ahead, I've given the D weightage, which is the maximum weightage to the reflexes. So both the characteristics, either it is short stopper or a sweeper, both must be having very good reflexes. So that is why I've given the weightage D to both of them. So that is how you can assign weights to all of them. And then what you can do, you can simply plot them and then pick the best one. So what I'll be doing, I'll be first plotting my short stopper. Now over here, what I have done, I have simply plotted a bar plot wherein I'll be passing the variable that is GK short stopper and then using the function sort values, we have arranged them in the descending order and then I just want the top 5 of them. Then on my x-axis, I have the name of the players and on the y-axis, I have the short stopper score. So based on these parameters, you'll get a graph somewhat like this. Now, it is quite evident from this graph that Manuel Neuer is the best goalkeeper. As you can see, he tops this chart. Now let us plot the other parameter that was sweeper. So I'll just copy the same code. I'll just pass in the value that is GK sweeper and then pass the same in my sort values function and then arrange them in the descending order for the first top 5. So over here again, we have the player's name on the x-axis and we have the sweeper score on the y-axis. So as you can see over here, Manuel Neuer tops the chart here as well. So based on these two parameters, we conclude that Manuel Neuer would be the best choice goalkeeper for this World Cup. So by going through the two characteristics that were short stopper and sweeper, we came to a conclusion that Manuel Neuer is my best choice for a goalkeeper. So let me just go back to my presentation and let's see what all we have covered. So we have seen this, we have collected the data and we have imported the required libraries. Then what we have done, we have analyzed the data, we explored the data set wherein we have plotted two count plots, one with the nationality and the other one with the age. So by plotting these two graphs, you basically find out a relationship between one variable or you can say one column and another column and then you can predict better results. So analysis, exploring a data set and visualizing them brings you a lot of insight. So you should definitely do that. Now, I've already told you that you can go through the data set, you will find a lot of columns, you can just pick up the ones which are relevant for you and then you can start your analysis on that. Next, my second step was to analyze my best goalkeeper. So over here, I have plotted two graphs, one with a short stopping score and the other with the sweeping score. So as I told you guys that a short stopper who is quite strong in stopping the shots taken by the opponents, whereas the sweeper is the one who is strong in playing with his feet and making the passes. Now, when we plot these two graphs, we come to a conclusion that Manuel Neuer is the best goalkeeper for this FIFA World Cup, and hence we chose him. Now, next in our quest to find the world's best playing 11, it's time we choose some defenders as well. Now, in order to find the best defenders, I'll be using these attributes to fetch the best defenders. So, as per my position, I am using 4-3-3. So, I need to fetch 4 defenders. So, here I'll be fetching 2 center backs and 2 wing backs. So, in center backs, we need 2 center backs, that is one who plays from the left and the one who plays from the right. So, here we have LCB and we have RCB. Just the positioning is different. Then we have wing back. So, again, we need 2 wing backs, one who plays on the left hand side and the other who plays on the right. And based on these parameters, I'll be predicting the 4 best defenders. So let me go back to my Jupyter notebook and let us plot each one of them and find out who are my best defenders. So as discussed guys, I have taken DF center backs, that is defender center back and defender wing backs. Now I'll be using the same characteristics for left center back and for right center back. And I'll just change the positioning. Let's say I want to know the who is my best left center back, so I'll give the position as LCB. And if I want to know the right center back, I'll give the position as RCB, that is right center back. So that is how we can sort the players by assigning the positions to them. Now, if I have to calculate the center back, I should know that they should be having a high defending capabilities. So the interception, the tackling power, the jumping, then your stamina, marking, all these things should be high. So if you see over here, I have my sliding tackle and standing tackle as D, which is the highest weightage. So that is why I've assigned the weight D to them. Similarly, I've given D to marking as well, then to heading as well. So that is how you can give weights to all of the parameters. Now for wingbacks as well, you must be having high defending capabilities. So the interception should be high, the tackling power should be high. So here also I've given the standing tackle and sliding tackle as the weightage of D. Then I've given acceleration to D and let's say finishing to A because a wing back is not that involved in finishing. So that is why I've given the lowest weight, that is A. So now is the time we plot the center backs. So here first we'll plot the left central back. So over here if you see I've given the position as LCB and then it's the same code guys, I've just passed in the values of center back and using the sort value function I have arranged them in descending values and I need to print the only top 5 values. Then on my x axis I have the name and on the y axis I have the score of this. Also notice guys that I have given a position LCB, that is the club position. So if you have explored the dataset, you can actually take any other column. Let's say you also have a column of national position. So you can take up that position and then you can find out the results. But for now I have used the club position because the player plays the best in the club. So that is why I have taken club position. Now you can go ahead with the national position as well and then you can perform the analysis. So do let me know what is your result or what is your take on the national position and then we can see the results as in how different our results come out. So do let us know about your result or your list that comes up after taking different parameters and different weightage and everything. So guys, this is my list based on these parameters. So you can just go ahead, analyze the dataset and you can actually do wonders with the dataset. Now, if I see the result of this particular graph, I have Sergio Ramos as my best left central back. Now, let me plot the right central back as well. So over here, I'll be giving the club position as RCB and then the whole code is the same. So let me just see the result. So my best right central back is Cesar Ekpilicueta. So now, next let's move ahead and plot the wing backs as well. So over here, let me plot the left wing back. So here I'll be giving the position as left LWB or you can say LB. So LWB stands for left wing back and or you can say left back. And then it's the same exact code. Over here, my left winger or you can say left wing back is David Alaba. Since David Alaba's team does not qualify in this World Cup 2018, so I'll be picking up Alexandro as the best left winger defender. Then it's time to plot the right wing back as well. So over here I have given the position as RWB or you can say right back. So as per this analysis, it is evident that Kyle Walker is the best right wing back for the World Cup. So that is how we have calculated the 4 best defenders, that is 2 central backs and 2 wing backs. Having said that, I got a list of my 4 best defenders. So let me just go back to my presentation and show you them as well. So over here, I got the result as left wing back as Alexandro. Then we have central back as Sergio Ramos. Then we have right central back as Cesar Espilicueta. And we have the right wing back as Kyle Walker. So moving ahead with the world's best playing 11, it's time we choose some midfielders as well. So as per the game formation that was 4-3-3, I have to choose 3 midfielders. Now in order to find these, I'll be analyzing the data for these parameters. So over here I have a controller, a playmaker and a beast. Let me explain you these terms. Now a controller is the person who is orchestrating your midfield engine by either sitting back or going forward based on the dynamic need. Secondly, we have a playmaker. So a playmaker is someone who will move the ball to the attacking from defense or you can say midfield. Then we have a beast. So a beast is a typical box to box player with loads of energy and who can basically boss the midfield. So that is how I have categorized the midfielder in terms of controller, playmaker and a beast. So let me just go back to my Jupyter notebook and let us implement and give weightage to all the characteristics. So as discussed, we have a controller, a playmaker and a beast. Now when I talk about controller, I have given the position of controller as LCM or you can say left midfielder. The controller must be good in passing the ball, then you have dribbling. So basically the characteristics that involves the highest weightage is ball control, then you have composure, you have short pass, long pass and all those things. So if you see over here in controller, I have given D weightage to the ball control. Then we have short pass, long pass. So we have given that weightage. Then we have a playmaker. So a playmaker is someone who will move the ball to the attacking from the defense or midfield. So a playmaker must be having good dribbling. The agility should be very high. Then the ball control. Then you can say short pass and long pass. Everything should be high. So over here I've given D weightage to the ball control. Then D for the dribbling. Then for the short pass, long pass, and similarly you can assign weightage to all the relevant characteristics. Then we have a beast. So a beast is basically a box to box player with lots of energy and basically who can boss the midfield. So he is the one who will be playing from the position that is RCM or you can say RM. So he'll be becoming a right central midfielder. Now, in order to find the best beast, what should be his plus point? So, I want that beast to be strong in defending as well as physical. So, in defending, you have interception, strength, tackling power. Then, in physical, you have the speed, stamina, agility, and all those characteristics. So, I have given here D weightage to the agility. Then, it must be having good stamina. So, I've given D weightage again. And similarly, I have assigned the weightage for the relevant characteristics. So over here, I have just assigned the weightage of all these three and now is the time you need to plot them. So the very first plot is to plot a controller. Now when I talk about controller, I told you that I'll be giving the position of LCM, that is the left control midfielder or you can say LM. So over here, I have just added one column that is club position, LCM or LM, and then I have just sorted the values. So as per this analysis, I'm getting the best controller or the best left controller midfielder is Iniesta. Next, what I'll do, I'll be plotting playmaker as well. So in playmaker, I want the position as CAM, that is center attacking midfield, or LAM, that is left attacking midfield. So over here, let us see the results. So the best playmaker or you can say the best center attacking midfielder is Mesut Ozil. So we have already come to two best midfielders. That was Iniesta and Ozil. Next we need to plot the beast. So over here I've given the position as RCM or RM and then we have just plotted it. So let me just see the results. So over here, so as per the analysis, I'm getting Kante as the best beast or you can say the right central midfielder. So here we have completed a hunt of finding the best three midfielders. So let me just go back to the presentation and let me show you them as well. So here I have the controller or you can say the left midfielder as Iniesta. Then I have the playmaker as Ozil and we have the beast or you can say the right central midfielder as Kante. So now we are done with the best goalkeeper, we are done with the best defenders and we are done with the best midfielders. So now is the time we find some attackers as well. Now in order to find the best attacker, I'll be plotting the three graphs, which is for left wing attacker, then for right wing attacker and one for the striker. So a left wing attacker is a player who attacks from the left flank. Then a right wing is the player who attacks from the right flank. And a striker is the one who attacks from the center. So let me just go to my Jupyter notebook and let us assign weightage and then let's see the results. So over here I have three positions, that is left wing, right wing and a striker. So in order to have a best left wing, he must be having strong pace. Then he should also be good in shooting or you can say passing. So basically the attributes that contributes him is acceleration, speed, then the finishing of it, then crossing. So all these things are the characteristics. So here I have given the acceleration D. Then I've also given the finishing as D because attackers must be having high finishing and also the shooting capabilities. Now I have allocated both these characteristics as same because a left wing and a right wing both have the same capabilities. It's just the positioning difference. Over here if you notice I have given the same weightage to each one of them. And then when I'll be going to plot, I'll be just specifying the position to left wing and to right wing. Then comes my striker. So a striker is the one who should be good in dribbling, he should be good in ball control, reactions, then the finishing also should be high, the balance should be high. So all these things are the characteristics of a striker. So here we have ball control, then we have the balance. So here we have given the weightage D. Then we have high finishing. So again the weightage D. For heading also we have given D. And we have similarly assigned weightage to all the other characteristics. So now let us go ahead and plot each one of them. So here we have the very first graph which basically plots the left wing. So here I have given the position as LW, LM or LS. So on the x-axis I have the player's name and on the y I have the score. So now let me just see the results. So it's quite evident that the best left wing is Ronaldo. And now let me just plot the right wing as well. So over here I've given the position as RW, RM and RS. So I'll go to the results. Alright, so I'm getting Messi as the best right wing attacker. So here we have the left best attacker as Ronaldo and we have the right wing as Messi. Now comes the striker. So here I have just given the position striker to ST, or you can say left striker or right striker. So let me just plot this as well. So as per analysis, we are getting Robert Lewandowski as the best striker. So that is how we have calculated the best three attackers. That was Ronaldo, Messi and Lewandowski. So let me just go back to my presentation and let me show you there as well. So on my left hand side, we have left wing as Cristiano Ronaldo. Then on the right wing, we have Messi and striker as Lewandowski. So guys, this brings us to the end of this use case. We now have the best goalkeeper, 4 best defenders, 3 best midfielders and 3 best attackers. So let me just show you the complete picture of my analysis. So these are the world's best playing 11 for the FIFA World Cup in the 4-3-3 position. So here I started from choosing the best goalkeeper, that comes out to Manuel Neuer. Then we have picked up 4 best defenders. So my left wing was Alexandro, then it was Ramos, Cesar and Kyle Walker. Then we have gone ahead with analysis and then we chose the best 3 midfielders. So the midfielders that came out were Iniesta, Ozil and Kante. And finally towards the end, we have analyzed the best attackers as well. So on the left hand side, we have Ronaldo, on the right hand side, we have Messi, and on the striking, we have Lewandowski. So I hope you guys like these results. So I'll repeat it one more time, guys, that this list of players and the formation is totally based on my opinion, and you are entitled to have a completely different opinion. So if you do have a different opinion, do let me know about your list in the comment section below. So here I'll just wrap it up, and I hope you guys like the coverage of Python in this FIFA tournament. So guys, this is just one use case on FIFA dataset. You can actually achieve a lot more by applying various machine learning theorems. Then you can go through statistics and you can do wonders with the dataset. So this was just the beginning and this was quite a basic use case for the FIFA dataset. You can just go ahead with the dataset and you can actually apply machine learning and predict a lot of things.
Now let's start out by understanding what exactly is a recession. Yes? Now many economists say that we are overdue for a recession. Despite a low unemployment rate and the economy's longest expansion on record, experts and the World Bank point to trade wars and other globally financial risky situations as reasons for a dim forecast. In economics, a recession is a business cycle contraction where there is a general decline in economic activity. Recessions generally occur when there is a widespread drop in spending, which leads to an adverse demand shock. So basically, it will cause an increasing deficit and lowering interest rates all over the world. And hence, it's going to significantly affect employment, salaries, jobs across industries. Across most of the IT sector, the major cuts in salaries and jobs are more likely to happen in consumer focused sectors, including hospitality, tourism, and non essential retail. As these sectors have seen an acute fall in demand because of the lockdowns across different countries, they are expected to recover and reach pre recession revenue parity in 3 or 4 quarters of operations resumed. Now, while that is the case for most of the domains, research states that the impact of the ongoing recession on the analytics domain on a whole may not be as severe as its impact on various other sectors. The broader quantifiable impact of the recession on salaries across analytics can only be measured after a few months of the recession. By then, the impact of the recession on operations costs and demand for products and services would be felt across industries and organizations. Across the IT sector, even if the global and domestic economies have persistently slowed down, the impact of the current demand on overall operations would still be less significant as this sector provides strategic value to its global clients and consumers. So let's move on and try and understand what the Great Recession was, what it entailed, and what did we infer from that episode. Firstly, let's take a little time to cover what happened in the Great Recession of 2007-2008. The 2007 financial contagion and the subsequent Great Recession resulted in the loss of tens of millions of jobs, out of which 7 million were in the United States alone. The map that you see in front of you shows just how much it had affected each country across the globe, the red ones being the most affected while the grayed out ones were the least. Average income started to drop and higher government borrowing started to occur. The prices of the stocks and properties also fell, taking a real hit on the GDP worldwide. But here's the catch. The financial contraction did not treat all jobs equally. Nearly 80% of job losses occurred amongst workers with a high school education or lower. The remaining losses occurred amongst workers with some collegiate or associate degrees. The recovery from the Great Recession had been equally difficult for low skilled workers and those without college credentials, since the recession accelerated the transition to a knowledge based digital economy that rewarded high skill and college credentials. Nearly two-thirds of the 8.4 million jobs that were created during the recovery required at least a bachelor's degree, and nearly all of the remaining jobs required some sort of collegiate or associate degree. Only about a third of the new jobs required a high school degree or lower. Signs of the demand of the digital skills appeared as early as 2011. Data-driven industries were called the next frontier for innovation, competition, and productivity, which projected not only a shortfall of 200,000 data scientists, but also a deficit of 1.5 million analytics-enabled managers, and the talent gap was significant in the minds of employers. Let's move ahead and try and understand what you could infer from this Great Recession. What did we learn from this recession? Number one, a talent gap persists that is most likely to extend into the next decade. The 2016 Education and Workforce Survey identified the relevance and the need for analytic skills as crucial. 94% of employers said that these skills are very or somewhat relevant to the current job openings of their companies. 89% cited finding qualified applicants in this field as very problematic. And note that in both cases, these skills are the second most relevant and problematic field among 6 other science, technology, engineering, and math or STEM fields, illustrating that the need for analytic skills is particularly acute even within the larger STEM shortage. The next thing that we learned is that the majority of the job openings demanded for analytics enabled professionals. Analytics enabled professionals, including functional analysts, basically the people who use data and analytical models to inform domain specific functions and business decisions, and data driven decision makers, basically people who leverage data to inform strategic and operational decisions, represent nearly 70% of all job postings. The demand for these professionals are scattered across jobs of all domains. Jobs for analytics enabled professionals represented two-thirds or more in many sectors. And this demand is not limited to the technology or professional sectors alone, but also demonstrated in finance, health, manufacturing, and retail. The next thing that we learn, and also the most important in my opinion, is that structured talent acquisition need not necessarily work for the digital economy. As the march towards digitalization continues forward, new approaches to talent recruitment and development of incumbent employees will be needed. These approaches must be defined less by traditional career tracks such as collegiate grades and more by their set of data-driven and analytical skills which needed to build cohesive, multidisciplinary teams that can deliver business results. Companies started to invest in market-driven programs for their employees and also sponsor scholarships that linked learning with work in colleges. When creating a new undergraduate program, colleges try to create partnerships with business that made the learning meaningful in real-world ways. This often meant encouraging employees at the funding company to become involved in the program or expanded funded research to include undergraduate education. Think about moving from a transactional relationship between business and higher education to a more strategic partnership where both parties are involved in meaningful ways. Strategic investments in digital data-driven technologies are not likely to live up to their potential unless companies align their people and cultures with their strategies in more systematic ways. This, in turn, modernized education, training, and development for long-term employability. Which brings me to my fourth and final point, which is to expand the pathways that lead to a more analytical workforce across the domains. The key to developing new capabilities in the workforce was to offer employees the opportunity to build skills in new technology areas, followed by job rotations and on-job development programs to apply and practice these new skills. Employees were also motivated by the opportunity to expand their technical expertise and recognize the value of the investment that the company makes in their careers. Later, if not sooner, people started to invest themselves into learning new technologies to build a strong repertoire. All majors required some sort of foundational knowledge of data analytics and data science process. Data visualization is a great example of such knowledge. It fuses the art and science of helping students to use data to express themselves in creative ways, and also gaining insights from the data that they have acquired. In the end, the broad adoption and effective use of data and analytics added hundreds of billions of dollars in productivity over a decade. However, closing the talent gap and ensuring diverse workforce was something which is still required to capture this value. Most importantly, data-driven skills must be broadly applied to meet the demand of the current industry. Given the demand, the basic competencies have an outsized impact on the global economy. As the world generates even greater amounts of data, data-driven talent will be needed at all levels. Next, let's see how analytics can help us during a global recession. In a recession, finding ways to do business and spend less money becomes paramount. Analytics may not be able to tell you exactly when the economy might shift. However, data analytics can certainly help an organization mitigate the impact of a recession by giving you the right information to better target the right market, save money, and increase profits. The companies that respond best to an economic recession are the ones that are most prepared for one. And the good news in this case is that there is always time to prepare. Some experts suggest that the best time for an organization to conduct a digital transformation is just before a recession hits, while others say that this transformation should be done when the slowdown in sales begin. In either of the cases, this change is necessary. Acting before a recession allows an organization to be proactive rather than reactive with its data. And since it could take time to put the necessary tools in place, depending on where your organization is with its technology, it's better to already have the tools to navigate the recession rather than wait until after the dust settles to start from scratch. Analytics help companies figure out which aspects of their businesses are most likely to thrive no matter what the global economic conditions are. It may require limited focus, but by using the data to pinpoint which products do well in certain markets, a company can direct its energies to the areas it knows will continue to sell well. If a company is able to identify through the data customers who enjoy a particular product, the enjoyment is likely to lessen even in a recession, and the organization is likely to see an increase in profit from a direct to customer approach. In the advent of a recession, data analytics and business intelligence help save time and money. Finding ways to do business and spend less amount of money becomes paramount. Advanced analytics tools can help organizations figure out what tasks can be automated. For example, BI tools can be used to focus on customer engagement, identifying which accounts have been communicated with and whether or not there are accounts that require attention. This will increase the customer retention of said company. You could also point to other economic efficiencies that the company can take advantage of. And even if the forecasts are wrong and a recession is further away than the experts predict, only good things can come from taking the time now to come up with a plan from when the record expansion shifts to a downturn. It never hurts to be prepared, right? And the data that might help a company survive a recession could help it thrive in the current climate state. Next, let's move on to the impact of recessions on the analytics market. Now, from an expense perspective, analytic applications for financial analysis, customer profitability, and especially corporate performance management are likely to be closely evaluated. Some analytic applications, such as those associated with campaign management, can help generate additional revenues while helping to monitor and control expenses. When the threat of a recession arises, every source of revenue must be considered. Astute business people will try to maximize the revenue potential from their existing customers while attempting to attract new ones. They will also seek ways to reduce expenses and determine which departments, programs, and initiatives are performing below expectations. After all, a penny saved is a penny earned, and a company can increase its profits by both generating new revenue as well as reducing expenses. Apart from that, some organizations, particularly those concerned with defense and homeland security, have needs that are relatively independent of economic landscape. These customers and prospects are likely to cut back on their plans for deploying additional tech, but tend to focus more on fraud attempts and security trouble. In times like these, fraud tends to become more prevalent, and analytics can be used to track and analyze these attempts, and data mining can then be used to predict common characteristics of those likely to be involved in fraudulent activities. The bottom line is that analytics is not a luxury item that an organization can defer to in hard times. Rather, it is an essential aspect that can be used to identify new revenue opportunities, prevent fraud, and identify unproductive expenditures. Hence, these requirements keep the analytics market afloat compared to other sister domains. As you can see in front of you, the post-recession, when jobs were created, in every single domain, there is a requirement of analytics-based jobs. You can see the numbers on your screen, where you can see the demand for data analytics and data science jobs by sector and by job category. We have your finance and insurance, healthcare and social assistance, information, manufacturing, professional, scientific and technical services, as well as retail trade. So currently the coronavirus or the COVID-19 outbreak is having a growing impact on the global economy. Several nations, including India, UK, South Korea and China are under lockdown or just lifting up lockdowns, right? So these lockdowns, while effectively slowing the spread of the virus, are economically extremely harmful. The world is witnessing layoffs, furloughs, and pay cuts amidst the current financial crisis. So although a lot of tech and IT employees are feeling the heat, somehow the analytics sector is staying afloat during this phase. In fact, between February and March of 2020, job titles that included terms like data science and data analytics and machine learning were on track to increase by 11% at the time when the job postings for most occupations were falling. So let's go ahead and dig in a bit deeper, shall we? Let's look at how data analytics, big data, machine learning, and in general analytics trends work in every field. First of all, we have analytics in business. Now, analytics will help you save time and money. In a time like this, finding ways to do business and spend less money becomes paramount. Advanced analytics tools can help organizations figure out what tasks can be automated, how to retain customer engagement, and which aspects of business will thrive despite of the current economic climate. Business analytics makes extensive use of analytical modeling and numerical analysis, including explanatory and predictive modeling and a fact-based management to drive decision making. In such a case, analytics will develop new insights and help drive the business performance based on current and past recession data as well as statistical methods. According to a report in 2009, despite the recession being going on for the past year, the analytics market seemed to be booming. The reasons didn't seem to vary much. Basically, data analytics helped companies to not just identify cost savings but also grow profits. Not just that, a mid-year report found that data analytics and business intelligence software applications had the highest impact for companies over the next 2 to 5 years, pulling certain companies out of the post-recession hangover. It basically was a complete roadmap to understanding how data driven decisions and analytics had been successfully able to insulate organizations from the effects of the economic recession. And that in itself is a great reason to why this market stays afloat despite the global recession. In biomedical research. So, a lot of work is going on to try to develop a vaccine to find out whether there is any current drugs that work against the coronavirus. All of those projects require molecular modeling and analytics, and many of them are using machine learning and big data to map things we know about the virus in pharmacological databases and genomic databases. You can create models using these technologies that can eliminate false tracks and allow us to identify potential targets. So instead of trying 100 or 1,000 different things, researchers can now narrow it down to a much smaller size thanks to analytics, which will make the job much, much faster. This is going to accelerate the eventual finding of the vaccine. To make any real progress in this situation, you need to bring together people who understand computation and data, people who understand biological and biomedical implications, and people who understand statistics and population models. It's a very interdisciplinary problem, and to make any headway, the world needs data, and hence it needs big data professionals, analysts, and their academia. So the trained talent in the analytics industry obviously will stay afloat. Next, let's look at supply chain management and logistics. Now, from the shortages of personal protective equipment to a variety of grocery items to electronics and apparel, during any global recession, the global supply chain is expected to be hit in unexpected and unforeseen ways, and it seems likely that it would take months, even years, to recover sometimes. Now, bouncing back more quickly, you will obviously require supply chain managers to turn new ways of managing the supply chain using data from Internet of Things or IoT, analytics, and machine learning. These tools will become the foundation on which supply chain managers gain insight to their market and erratic supply on demand trends. Next, we have monitoring mobility and social distancing. Now, recently, the Newcastle University Urban Observatory has developed an urban data dashboard to help understand the impact of social distancing measures on people and vehicle movement within a metropolitan city in real time. The objective is to understand the dynamics of movement in a city using thousands of sensors and data sharing agreements to monitor movement around the city, from traffic to pedestrian flow to congestion, car parking occupancies, and bus GPS trackers. It also monitors energy consumption, air quality, and climate, and many other variables, all of which is acquired through sensory data. This type of data not only shows how physical distancing is changing in real time, but also provides us a detailed insight into long-term behavioral changes, all thanks to the ocean of data that is available to us and the analysts that crack it down and find patterns in them. Cities, enterprises, and national governments should collectively create a massive global network of sensors to detect viruses for future pandemics as well. This further will fuel the implementation of the smart city concept, which is very specific to each city but also catering to some global problems, despite the severe criticism it has received in the past due to data privacy issues. Next, we have controlling the pandemic situation through social media using data science and AI. Now, be it reaching to the target audience through cluster algorithms or identifying the at-risk individuals who are close to the infected individuals in terms of frequency and recency of communication through graph analysis. Data science and data analytics, along with some artificial intelligence tool, will have a big role to play by leveraging the social media platforms. Additionally, natural language processing, data mining, and predictive analytics are going to come handy in detecting fake news and analyzing people's movement in near future, including travel plans, destinations, and the number of travelers. Hence, you can say that you're using data analytics, predictive analytics, and cluster algorithms to leverage social media to combat the current pandemic. Then we have the use of cloud computing in making remote work more convenient for organizations and team members. Now, with so many people in self isolation for what could be as long as 18 months under estimates, and with a possible long term shift towards home based work for a large segment of the population, large scale deployment of the public 5G access points is likely to be curtailed. Now, the cloud capacity, especially from hyperscale vendors such as AWS, Microsoft Azure, Google Compute, Oracle Cloud, and IBM Cloud, is what is going to get us through the storm. With a remote home-based workforce, remote desktop technologies will be essential until native born-in-the-cloud applications can run core business functions. Legacy vertical industry Windows client-server apps are problematic and will need to be refactored and rewritten entirely in software as a service. This will occur using enabling technologies such as containerization and microservices because VMs and IaaS are computationally extremely expensive. Next, we have the edtech, fitness, entertainment, social media, and OTT platforms. Now, with people staying indoors, the demand for online learning, fitness, social media, and digital consumption has increased exponentially across the board. Video conferencing apps such as Zoom, Google Hangouts, Google Duo, and House Party have seen nearly 72% of increase in the time spent, while the average user count has risen by over 100% in each of these. Since users will be looking for more personalized digital content, the demand for professionals with solid skills in machine learning, deep learning, data science, and data analytics will go up tremendously. And then we finally have financial tech and financial services. Now, banking and financial services are essentially for everyone. With people working from home and maintaining social distancing, this would be a great opportunity for fintech startups. Online services that we can pay for through fintech are now practically